We have here an interesting problem to do with vectors. OACB is a parallelogram. OA equals A, OB equals B, and the points M, S, N and T divide these longer edges in the ratio 1:4 respectively. The lines ST and MN intersect at D, fair enough. Show that these lines, MN and ST, bisect one another. Where can we start? Well, I notice that these 4 points, because there are 4 of them, they will obviously make some type of quadrilateral if we join them up. And then I start thinking about the properties of quadrilaterals. I know that squares have equal and opposite sides. I know that the diagonals of a square cross at right angles. I know that a rhombus, again like a square, the diagonals bisect each other at right angles. But we don't know what type of quadrilateral this is going to be. The most general quadrilateral, which has the property that its diagonals bisect one another, is the parallelogram. If I can prove that this red shape is a parallelogram, then I will also have proved that the diagonals bisect one another. So I'm not going to start with this fact. That's going to be my closing line, if you like. But it's as I'm trying to work out what to do, it's the first thought I have. What do I know about shapes where the diagonals bisect one another? That leads me to the parallelogram idea. I don't know if it's a parallelogram, but I'm now going to try and prove that it's a parallelogram. Now, what do I know about parallelograms? Well, the obvious thing is that the opposite sides are parallel and the opposite sides are the same length. So I think what I'm going to do is I'm going to work with the vector ms, and later on I'll look at the other 3 sides of the red quadrilateral as well. Now ms is equal to mb plus bs, and mb is 4/5 of OB. And bs is equal to 1/5 of OA. I know that it's equal to 1/5 of OA because we've been told that this black shape is a parallelogram, and therefore OA and BC must be identical. So I can write the vector ms as 4/5 B plus 1/5 A. We'll come back to that later on. Okay, so that's ms. Let's look at Tn. The vector Tn is equal to Ta plus An. Ta, this is also in the ratio 1:4, Ta is 1/5 of OA plus 4/5 of AC. So I've got 1/5 of little a plus 4/5 of AC. Now AC, because I said it before, because this is a parallelogram, then AC and OB must be the same, and so I can substitute that in there. And we notice straight away these are identical. It might actually be helpful just though to rewrite that one in the same order as the first vector that I worked out, just so that we can compare them even more easily. So what I've shown here is that ms and Tn, not the vectors anymore, but the lengths of the line segments, ms and tn are, first of all, equal, and they're also parallel. I know they're equal because they're absolutely identical. I know they're parallel because one is a multiple of the other, and in fact it's just a 1 times multiple. Now, proving that ms and tn are equal and parallel does not prove that this red quadrilateral is a parallelogram. So far, I have proved that I have a trapezium. That's all I can say. I now need to go through similar working for Sn and Mt. So Sn, got that ratio of 1 to 4 again. Sn is 4/5 of Sc plus 1/5 of Cn. Now, just split this up so we can see what we're doing. What have we got? 4/5 of Sc. I don't mean that, do I? That's a mistake. 4/5. Let's get that vector right. 4/5. I'm being careless. Let me backtrack a little bit. What was happening there? I was thinking ahead into what's coming next, and I wasn't concentrating on what I was doing at the time. Let's try that again. Sn equals Sc plus Cn. That's better. It's a foolish error. And Sc is 4/5 of Bc. And Cn is 1/5 of Ca. Now BC is the same as OA, so I've got 4/5 A plus 1/5 of Ca. Now that Ca is equivalent to BO. It's going backwards, so I think what I'm going to do, I'm just going to do that for a line. Minus 1/5 of AC. I'm going to make sure I've got the order from A to C to match the order from O to B. Swap those around, make up for it with a negative, take an extra line just to be on the safe side. 4/5 A minus 1/5 of AC, which is the same as OB. There we go. That's the vector Sn. Mt. It gets a bit laborious, but you just have to work through them. Mt is equal to Mo plus Ot. Mo is equal to 1/5. Now we're going from M to O, so I need to put 1/5 of BO plus OT, that's 4/5 of OA. Now, as we've seen before, I'd rather that these letters were the other way around, so I'm going to put negative 1/5 OB plus 4/5 A. And so, to rewrite it in the same order as this, I've got 4/5 A minus 1/5 B. Okay, now then, we're nearly there. Just get that out of the way a bit. We deduced from these two pieces of working that Sn and Mt are equal and parallel. When I say equal, I mean equal to each other, not equal to whatever's happening over here. taking these two statements together, we now have two pairs of equal, parallel, opposite sides. That's the condition which tells me that we've definitely got a parallelogram. Might be worthwhile writing parallelogram, what are the letters for this? MSNT. And because it's definitely a parallelogram, we now know that the diagonals bisect each other, because that's a property of every single parallelogram. And the diagonals are ST and MN. So ST and MN bisect each other. And we're done.